Ladies and gentlemen, please welcome Raghuram.
Good morning. Yesterday, you heard a great presentation from Steve on the future of IT as a service as we see it. Today, I'm going to drill into the data center segment of that. This is a time of fundamental transformation for the data center. The data center, as we know it, is a world of specialized CPUs and specialized chips and silicon and specialized hardware. It's moving from that kind of a specialized hardware world to a world of standardized hardware blocks, where increasingly all the infrastructure functions that we know of will be developed and deployed in software. And even more importantly, the control of this data center is entirely done by software. The data center is on its way to becoming programmable and automated. So we call this the software-driven data center. Over the next 3/4 of an hour, I'll give you a glimpse of some of the aspects of this software-driven data center. So the first question to ask is, why now, right? Why is this change happening now? And there are three forces that are at their maturity today that are driving this change together. The first one is increasing hardware price performance. Second is the 100% virtualized data center. And third is the rise of new application architectures. Let's look at the effect of each one of these very quickly, starting with hardware. So this is a chart that should be familiar to all of us. This is the inexorable increase in price performance of hardware, right? Over on the left-hand side is the advances in CPU technologies. We are at this 22 nanometer technology space, which means that a standard silicon chip can carry up to nearly 3 billion transistors, which means you can put a heck of a lot of processing power on a single CPU. The same set of manufacturing technologies are yielding great improvements in memory prices as well. Not only memory prices, but memory density, which means the ability to pack more and more memory in a given server. So the result of this is we are in the middle of one of the most historic increases in capacity in an average system that we've seen. By 2013, the average CPU will have the average socket will have 32 logical CPUs, 16 cores times 2 threads, and an average system would be capable of carrying up to 2 terabytes of memory. These are massive numbers that were unheard of even a few years ago. So we are squarely in mainframe territory when it comes to industry standard servers. The result of this is that the average server being used for virtualization, the cost of which is coming down pretty dramatically. So those of you that have done virtualization in the past, in the early days of virtualization, 2003, 2002, etc., probably remember that the canonical configuration for a virtualized server was an 8-socket system. The first system, in fact, was an IBM 440. And that cost several tens of thousands of dollars. That curve has steadily dropped to the point where we think it's going to hit around $5,000 per virtualized server, according to IDC. And this curve is going to accelerate even further, right? So now what this means is this. On the one hand, you've got the actual raw cost of compute coming down. At the same time, you've got the capacity of every unit of compute going up. So you start to have a multiplicative effect in terms of the capacity available to you in the data center to do software. In fact, there is so much capacity that's going to be available that besides your commercial business applications, you will have enough capacity left over to incorporate infrastructure functions that were traditionally done in specialized ASICs and specialized chips. We see this trend only accelerating, not decelerating. So that's the first part of what's going on. The second part of what's going on is, of course, virtualization. A few years ago, people were questioning if virtualization would cross 50%. Now, the question being asked is, when is it going to hit 100%? This number has been growing very rapidly, depending on which industry analyst you believe. We are somewhere just around the north of 50% mark, and rapidly heading towards a world where pretty much any commercial application you can think of is fully virtualized. So the applications that people are considering virtualizing today have gone from the virtualization applications that are running on physical x86. They have done that. Now everybody is focusing their attention on business critical applications running on RISC CPUs on proprietary Unix. So this is the first aspect of the world becoming standardized around a virtualized x86 data center. As the world becomes standardized around a virtualized x86 data center, the data center architecture itself can be simplified. It can be optimized towards virtualization. And that's what we are seeing now. Over the last 2-3 years, you're seeing convergence being a hot term, and this is happening on many fronts. Convergence on the I/O side certainly is a big deal. 10 gig networking was going along like this until virtualization took steam, and now data centers are deploying 10 gig on a large scale. And that number will soon become 40 gig networks, carrying both storage and regular data traffic, and voice and video and what have you. And converged I/O in turn simplifies the hardware configuration coming out of the back of the server, which again means that you can standardize and lower the costs. I just talked about the convergence on x86 CPUs for practically all workloads. So we know the traditional x86 workloads. We just talked about the proprietary Unix workloads. Next up are the new world workloads that I'll talk about in a few slides, as well as traditional infrastructure functions. Now, given that most data centers will be running largely virtualized infrastructures, allows data center operators to optimize their whole data center designs. A classic example of this is a data center in Las Vegas, data center operator in Las Vegas called SwitchNAP. In fact, the VMworld Labs equipment runs on SwitchNAP, and they have created a data center design that allows for extremely dense power supply per square foot of the data center. What that means is that it can rack these servers as high up as possible, which means extraordinarily high consolidation and extraordinarily high density. In fact, going forward, the data center operators would start to measure their density in terms of the number of VMs per square foot that they can deploy. So that's going to become a distinguishing characteristic. Now, this is not really the large data centers. At the same time, you're seeing innovation happen from the likes of Facebook in terms of their open server design. You're seeing innovation happen from the likes of vendors that are introducing new container-based models to take into enterprise premises. In short, virtualization is redefining not just the server and the compute and the storage infrastructure, but the actual physical layout of the data center itself. So the result of all this is what? The result of all this is hyperdensity, by which we mean a very high number of applications or VMs running on a single server. In fact, if you project those curves that I showed a few slides ago, where you will end up by 2014 is an average 2 CPU server, less than $5,000, right? Could carry up to 320 VMs. That's a mind-boggling number. If you project that out over a few racks, an average fridge the size of a dorm room fridge, right, could very well serve the data as a data center for a lot of our customers. About 60% of our customers have less than 1,000 VMs in their data center. That's fully virtualized, right? About 75% have less than 2,500 VMs. So if you're a customer that falls into that bracket, a half a cabinet at a switch-NAP-like data center could serve pretty much most of your computing needs. Now, clearly, you will have storage and you'll expand more than that, but this gives you a sense of the scale of consolidation happening, not just in the core compute, but in the entire data center. The third factor that's driving all this is new application architectures. What do we mean by that? The application that we are running on our servers is changing rapidly. It's no longer the old client-server applications. It's applications designed for the web. It's applications designed for mobile, applications designed for social interactions, etc. Up and down in Silicon Valley, you can always go meet startup companies that when they plug into Facebook APIs for the first time, their entire site goes down. The reason is you face the Facebook fire hose and direct it towards your data center will collapse, right? The applications that your developers are building are increasingly going to be social. They are increasingly going to plug into Facebook. They're going to plug into Twitter. If you've got a web-facing application, that's almost mandatory these days, right? When that happens, you'll be subject to the same deluge that these startup companies that are working with Facebook are, right? So whether you like it or not, your application is going to become massively scalable. The other reason your application is going to become massively scalable is the rise of mobile devices. So every user is accessing your enterprise application from potentially at least 3 devices, if not more. And if you're a web-facing application, then it's being accessed not just by the employees, but the thousands of customers that you have. So scales become a necessary characteristic of every enterprise application. Besides scale, these applications are being written in a different way. They're written to new frameworks, even though the slide only shows the old frameworks. There were supposed to be some images to the right of Rod Johnson in the Spring framework there. These new frameworks, again, are built such that developers can build large-scale distributed applications very easily. So these distributed applications require a very different set of infrastructure underneath than your traditional client-server application. And last but not the least is the growth of data, which has been much written about. The growth of data is requiring new data models, new databases, new types of data storage schemes with all kinds of funny names like Cassandra and React and so on and so forth. So the traditional model we are used to is over on the left, right? $1 million plus Oracle system running using $1 million plus SAN. These new systems process so much data that to deploy them using a SAN would be prohibitively expensive. The amount of bandwidth they would need in order to process the data or transport the data is so high that conventional SANs cannot provide to be cost-effective solutions. So these new solutions use local disk in a big way, right? So this is what I mean by saying new architectures from application perspective define new infrastructure from an infrastructure data center perspective. So if you combine all these 3 forces together, right, you get not only a new architecture for the data center, you need a new operating model as well. Because now every data center operator is talking about a scale much larger than what they had. They're talking about a set of infrastructure gear much different than what they had. And they're talking about SLAs and operating parameters that are much more stringent than what they had. Now, the good news is the industry has already started solving this, right? The large-scale web data centers have figured out how to solve this problem. And their world looks fundamentally different than the world that we are used to in the enterprise data center. Applications are no longer static or location-bound by virtue of their hardware or network or storage connectivity. They can be elastic, they can be mobile, and therefore you can run them anywhere in your data center, which means you optimize your entire capacity of the data center, which means you get a lower cost per application than you could ever imagine before. In fact, if we project the trends that we've been talking about, we think we can get to less than $100 a VM per year. The VMworld Labs here is something that most of you will try while you're here. And the labs is actually an early proof point of this. So we have costed out that the labs are running in probably about, before they're done, they'll be running about 4,000 VMs an hour, which means in every hour, 4,000 VMs are going to get created and destroyed. They're scaled for about 10,000 VMs in all. And a 10,000 VM rack, we have computed, costs about $15 to $20 a VM a month if you project it out. By way of comparison, if you go purchase a 2 gig VM from Amazon, it'll cost you $80 a month. Right? Now, the VMware Labs is a very specialized deployment, and not every data center can deploy that kind of a footprint. However, it's an early sign of things to come. So that's the first big benefit. The economic benefit is so compelling for this new model that enterprises will migrate to this. The second big change that happens in these new data centers is how these data centers deal with availability or failures, right? So the traditional data centers, the most expensive and complex part of the operation is how you deal with failures. This is why you deploy hardware clustering, which is very expensive. This is why you have your most expensive staff carrying 24/7 pagers so that you can troubleshoot things quickly, right? And this is why you do a lot of things in the data center. The new age data centers take a completely different approach. They believe that hardware will fail, and they count on the software to smartly redirect around the hardware failures. So this is another example of software substituting for hardware function. And if you believe that you can get the software to recognize failures and overcome that automatically without disrupting the application, then something fundamental happens to your economics. Now, instead of having those 24/7 contracts, instead of trying to fix the hardware as soon as it's broken, instead of trying to have a spare for everything that could break, what these internet data centers do is when a failure happens, nothing happens. The software just carries on. At the end of the week, they send somebody into the data center to replace the broken part, substitute a new server or a new disk or what have you, and life goes on, right? This fundamentally changes how you think about how you operate a data center. Now, this is all done through software. The last aspect of the data center is you go from a world of manual operations and fragile scripts to the notion of a completely programmatic data center. Every aspect of the data center can be programmed and controlled through software control as opposed to being controlled through hardware control and management consoles. Sometimes this is called the programmatic data center. The benefit is you can apply automation across a large scale in a repeatable fashion, in a policy-driven fashion, to get to very high numbers of admins per VM. Very high number of VMs per admin. So these three characteristics define the new age data center as compared to the old data center. All three are driven by new software elements that are now controlling what gets done in the data center. Let's talk about each of these. Like I said before, this has been done today, but it's been done in very few data centers. It's been done in data centers deployed by companies that can afford to employ thousands and thousands of computer science PhDs. But what about all the other enterprise data centers of the world? This is VMware's mission. We believe we can bring the model of a software-driven data center to the enterprise customers in their enterprise deployment. And because this is an enterprise deployment, you have to deal not only with the traditional the new age applications, but you have to deal with the traditional applications as well. So this, in its sense, is the challenge of the software-driven data center. How do you take the hardware that you got, pour VMware software on it, get to this model of the data center that we've been speaking about, and have it support not only your existing applications, but the new applications? So that's the challenge we're embarking on. And it's not just us, it's our partners in the industry as well. And the challenge can be thought of in 3 levels. First is, what does the core virtualization platform itself have to evolve to? How does the hypervisor have to change? Secondly, the unit of deployment in the data center increasingly is a pod or a rack, right? And in that rack, what gets done as hardware, what gets done as software changes. So we are redefining the hardware-software boundary. And then as you put these racks together into a federated large-scale data center, then you apply a next degree of automation and policy on top of that. So let's touch upon each one of these, starting with the hypervisor itself. It's popular to say that the hypervisor is a commodity. It's not proven to be a commodity in the last several years. Even more so in the next several years, it's not going to be a commodity because it's got to deal with the aspects of new applications as well as existing applications. Today, we've got 2 worlds on the cloud. Infrastructure as a service, which is a way of running existing applications, put them in VMs. And then platform as a service, which is providing higher level application constructs, whether they be messaging or object services or caching services, etc. As we go down this journey, what we will see is virtualization platforms evolve in order to support both existing and new applications, which means some of these services that we think of as application-centric services will become more natural hypervisor services. All the applications that you see out on the web today, the applications that your developers want to build, they're all highly distributed applications that talk to each other using messaging protocols, that save state using caching and other technologies like that. So the modern-day hypervisors have to be attuned to these kind of application needs and have to evolve to provide a higher level of services. This is an area that's ripe for a lot of innovation, and this is where you'll see the next generation of innovation in core virtualization platforms. The second part of it is putting together a rack of servers and storage and network to create this core computing unit, which is a rack or a pod in a modular data center that's composed of a collection of these racks and pods. So if you walk into many of your data centers today, many of you run VMware, many of you run VMware clusters. These VMware clusters are maybe 4, 8, maximum 16 nodes. And what you've done really is gone from one server, one app, to a few servers, few apps. You've still not exploited the entire power of the capacity that's available in your data center because of all the constraints of running these tiny silos of clusters. These constraints are not from core compute. These constraints come from storage, networking, security, how these are traditionally designed for the old data center. So if you really want to get to this notion of a standardized flat data center where any application can live anywhere, it's not just the compute that has to change. It's the storage, network, and security that has to change. Let's talk about storage. So all of us are familiar with the old storage hierarchy, right? You had applications that use disk or network storage, and then if you wanted to back it up, you put it to secondary disk, and then eventually you archived it to tape. Now, there is a new hierarchy in storage that's emerging. The first level hierarchy is your local disk and flash, because these are becoming very viable candidates to store application data. In fact, some of the new applications I talked about, like Hadoop or Cassandra, they are built to live off the local disk, right? So that's the first tier of storage. The next tier of storage is what we call scale-out network storage. And this is storage that can scale out with the compute layer as wide as the compute layer goes, right? So this is all normally IP storage. This is usually not fiber channel storage. And this provides a global namespace so that you can invoke a VM wherever you want to and have the disks be accessible. And then finally, you've got blob storage, which is used to store your images, photographs, other static content that you write once, store it in a very cheap manner. Amazon has done great things with their cloud service, AWS. But the greatest thing they've done with AWS is created this notion of S3, which is in fact the largest storage system in the world. Anybody that writes a web application throws their JPEGs and images onto S3. So that'll become a standard model for web applications. So what you now have is this new three-layer hierarchy, and the role of software now management becomes how do you place these objects, the data objects, in the right level in the hierarchy at the right time and move them around. By the way, the local disk being translated into usable storage, scale-out storage, and blob, all of them are nothing but storage software running on industry-standard hardware, right? The new data center storage is all about software. Two aspects of software. One is the primary storage itself, which is just code running on top of industry-standard hardware, and policy control, which governs where the storage lives, where it should move, etc. The combination of these two provides the combination of great economics, right? Now you're talking about storage economics that are $1 a gig or less as compared to the tens of dollars of enterprise storage, as well as great automation in terms of optimally placing and managing the disks. The third aspect of this that's made possible by today's technology is the fact that almost every storage system is going to be storing VM images of one way or the other. If the data center is 100% virtualized, if the applications are 100% virtualized, then it means that data is just living in virtual disks. So for the first time ever, we have a standard unit of storage in the industry. It's no longer LUNs versus files versus objects versus what have you. All storage vendors are now optimizing to most efficiently store virtual machine disks, move them around, manage them, compress them, dedupe them, etc. So this is not a trend just that VMware is pioneering, right? This is a trend that the entire storage industry is going down the path of. Storage has traditionally been the most complex aspect of data center deployment. After we are said and done, storage is going to become the most natural part of data center deployment, as easy as compute, relatively speaking. So we talked about how to get storage to scale. The magic is software. How do you get networks to scale? The magic, again, is software. In fact, the magic is network virtualization. What network virtualization does is takes the network services, the core access, the load balancing, the security, etc., takes it out of being assigned to and fixed to a particular piece of network gear or a network segment and assigns it to the application, makes it a software entity that lives with the application, moves with the application. As a result, you get two benefits. One is your network becomes simpler, because what the network is doing is just moving packets around as fast as it can, and the network services become software. Just like in the storage world, we talked about dynamically provisioning the storage when an application needs it on the right storage medium. The same problem exists here as well. So when an application A needs to communicate with application B, you can now create a network path for it dynamically on demand. You don't have to pre-wire your network. Since you don't have to pre-wire your network, you have ultimate flexibility. Today, in fact, one of the biggest constraints to scaling your application deployments is the fact that when you move an application from, let's say, one rack in the data center to another part of the data center, you will have to reconfigure the network. With network virtualization, that goes away. Provisioning and automation can now be applied because now you're deploying these network services as software services. And because you're deploying these network services as software services, you can scale them out as demand comes in. You don't have to buy a massive load balancer ahead of time. You can deploy a load balancer for an application. As the traffic increases, you can deploy another instance of the same load balancer because they're all virtual appliances. Once again, this is not something just VMware is pioneering. This is the entire industry moving this way, turning networks into software entities. This is sometimes called the software-driven network, and this will be the next generation of innovation in networking. Last month at VMworld in Las Vegas, VMware, working along with partners such as Cisco and several others, introduced a new technology standard called VXLAN. VXLAN is designed to address this problem of network mobility, right? Now, if you think about it as an analogy with the physical telephony world, in the physical telephony world, we all started out with landline telephones, right, wired to our homes, which means if you moved homes, if you moved outside your home, the telephone number was no longer relevant to you because you could not take calls anywhere, right? Along came mobile telephony, much later in the US than anywhere else, but it did come, and now finally we have number portability, which means wherever in the world you go, you've got the same network identity. If you think about that, why doesn't that exist in the physical data center world today? Shouldn't it exist? The answer is it absolutely should. In fact, in a world where applications are virtualized, it's an absolute requirement that as these applications move around, their network identity does not change. So what number portability and wireless telephony did for personal communication, VXLAN will do for application and VM communication. This is a profound step. This is a step that we are just taking. We have submitted it as an IETF standard, and a number of networking industry participants are working along with us in turning this into a definitive standard. A quick primer on how it works. The problem with virtual machines today in a conventional physical network is when you want to move, the virtual machine has a MAC address, a layer 2 address for those of you that are familiar with networking technology. And when you want to move it from one network to another network, so it's a different set of, it's a different IP domain, so you have to issue a completely different set of network identities to make this happen. As a result, you will have to reprogram every aspect of your network. With VXLAN, what we do at a virtualization layer is we encapsulate the MAC address into an IP packet. Technically, this is called sending layer 2 over layer 3. But basically what it means is that we pretend that these things are regular data packets running over a regular internet network, and that fools the underlying internet network and gives the networking control to the virtualization layer. So the virtualization layer takes the payload, encapsulates it, sends it over the physical network to the other VM on the other destination. This can be done at the virtualization layer. This can be done at the hardware switch, the top of the rack switch as well. This can be done at the NIC as well. So that's why we've got all these partners that are working with us in order to implement this. Closely related to networking is security. Yesterday, Steve talked about security in a multi-tenant world where you want to protect, because you're living in a shared infrastructure, you want to protect each tenant and then each application within a tenant from interfering with each other. If you recall, this was the nosy neighbor problem that he talked about. We are well on our way to solving the nosy neighbor problem. But if you step back and think about it, the notion of security is very ill-suited to this world that we are coming to. Traditional security depends again upon machine IDs and network identities, right? So firewalls, for example, they give you a source IP and a destination IP, and they say which of these are allowed to talk to each other, right? And very quickly, this becomes a hairball. That's what that is supposed to represent, a hairball. When networks become very complicated, when applications become very complicated, when you've got a number of devices. Now, think again about the picture that Steve showed yesterday, where he said the cloud is about two things. It's about people, it's about services, right? And people being able to securely access services. In order to implement this, you got to recognize that the services themselves move around in the data center, like we just showed. And people also move around on different networks on different devices. So security has to go from being tied to the notion of machine networks and machine identities to be about knowing what the identity of the person is and what the identity of the application is, and whether there is a business policy that allows the application to be used by that person. This is the next generation of security innovation because of two things. One, this is what you need for the cloud. Secondly, if you look at a lot of the security problems, a great deal of the problems is due to the complexity of prescribing which machines and users can talk to each other. Now, if you can take it to a higher level of stating users with their group identities being allowed to access services on the cloud, then you have created a security policy language that can then be translated automatically into underlying machine rules by software, which means less room for human error. So this is not only a way of efficiently improving security, this is how we believe the security will get done for the cloud. In order to do this, once again, you can't have hard fixed appliances in a network data path that you can't move around, that you can't scale. You got to have security appliances that are virtual, that move with the application. So we talked about how you got to break the boundaries of storage network security to create this new scalable unit in the data center. Then you got to connect up all these scalable units, federate them into a hybrid cloud. We introduced this concept called virtual data center. The virtual data center is a set of applications and data surrounded by policies and infrastructure services that you as an enterprise IT owner would want to deploy in whichever data center you want, whether it's your own internal data centers across different parts of the globe or at a service provider. In order to do this, a number of new software technologies have to get developed. We talked about VXLAN. We talked about global file systems and being able to move your data where and access your data wherever you want to move your applications, moving security, and so on and so forth. But there is also fundamentally a management and operations problem as you get to this level, because you're dealing with large numbers of virtual machines across large numbers of locations and multiple administrative domains. So the next great piece of software that will emerge in the data center in terms of data center automation is this thing that we are calling the cross-data center placement and provisioning engine. In a data center at scale, if you want to truly automate operations, you want to be able to place the application in the right portion of the data center without manually having to calculate all the possibilities. The reason it's so critical to get the initial placement right is if you put it in the right part of the data center where the application has the performance it needs, it gets the I/O throughput it wants, etc., then you've solved a number of eliminated a number of downstream performance and SLA problems. Similarly, if you put it and attach the right set of availability services to it, then you can avoid a number of downtime issues. If you place it in the right part of the data center where the right security capabilities are available, then you avoid a whole set of compliance issues, right? So we call this intelligent policy management, and this has to go from beyond the boundaries of a single virtual center in a VMware universe, right, to the entire data center. In the future, applications and application owners will come to the data center with a manifest, if you will, a set of requirements that describes the availability needs, the security needs, the recovery time objective, etc., the performance objectives. And then the software will interpret this, find the right place for this particular application, and deploy it in that particular application at the optimum cost, right? So this kind of software currently runs in airline networks and other sophisticated networks, manufacturing networks, etc., where you want to place your objects or passengers or air transport vehicles in the right location at the right time. This is a similar problem. Besides placing it at the right place, the other big challenge in the cloud, of course, is security and compliance. Today, we think of the compliance world as two distinct, non-overlapping entities, right? So you've got your data center, which is highly compliant, authenticated, encrypted, etc. And then you've got the public cloud, where anything goes. Compliance has to move from being an attribute of a particular data center location where you're doing business to being an attribute of the kind of services you want, compliance services you want to deploy, regardless of where the application is. So whether it's in a public cloud or in a private cloud, you want to be able to apply the same kind of data activity monitoring, endpoint protection, firewalling, compliance regulations, DLP, etc. So to be able to do this in a cloud-independent and a cloud-agnostic manner requires for a whole new compliance infrastructure. The last part of the operations challenge is dealing with day-to-day operations. So if you look at the set of real-time events and metrics that are coming into the data center, right, and you've got customers calling you saying something's wrong, you cannot go back and look at data that is 4 hours old or 8 hours old. You need to be able to look at data in real time. And this data could come from hardware performance metrics, software events, security, administrative actions, etc., right? Application actions, so on. This is a huge data deluge. This is, in fact, a big data problem. So we had a customer come to us a couple of weeks ago that has been using our vCenter operations product. They're collecting data from 49,000 devices, half of which are VMs, and the rest are the pieces of infrastructure or applications that support these VMs. They are getting about 500,000 metrics an hour, right? This is not a cloud provider. This is just a large enterprise. So in this world, traditional enterprise software management techniques completely fall by the wayside. You can't even begin to process these, right? So you need new techniques to deal with this big data problem. And that's why we created the vCenter Operations product, which uses statistical techniques to determine problems before they happen, likelihood of problems before they happen, and help you resolve the problems as rapidly as possible. It also allows you to filter data in a much more intelligent way. As these kind of statistical techniques become normal in a data center, we think it'll allow you to get to the next level of efficiency, because you'll now be able to tackle problems that you previously did not want to even encounter, and therefore were not willing to take a risk on. Now you're able to deploy your data centers to higher levels of efficiency, because you're now guaranteed that you can solve problems as they happen in real time. So we looked at a wide swath of technologies, right? Starting from the core compute through to the hypervisor, storage, network, security, management, operations, compliance, etc. Where does all this go, right? What is the end state we want to get to? The analogy is, just like you can assemble 1,000 different kind of things from the same standardized set of subatomic particles, the modern data center follows a similar path. We want to start with a certain core set of industry building blocks, the core x86 hardware, and through the magic of software-delivered data services, software-delivered infrastructure services, and intelligent policy management, you are able to construct a data center to any given specifications. That's what we call the software-driven data center. This is already happening, like I said, in a big way. And this is happening not only in the big data centers. 90% of storage devices today are just software running on infrastructure. Network packet processing is already migrating heavily to the Intel architecture as software, right? So this is happening today and accelerating over the next 3 years as we get to the software-driven data center. Our role in this world is to lead this transformation and help you get there. Thank you very much.